The second factor which affects the position of equilibrium is the temperature. So what will be the effect of temperature on position of equilibrium? In terms of temperature, the reaction can be classified as endothermic or exothermic. These are the classification. Endothermic reaction means the reactant absorb energy and form the product, and exothermic reactions means the reactant release energy to the surrounding, so the surrounding temperature will increase. In endothermic reaction, if we make an energy diagram, energy profile diagram for endothermic and energy profile diagram for exothermic. In endothermic reaction, which substance is having a greater energy, reactant or product? In endothermic reactions, which substance is having a greater amount of energy? The product is having a greater amount of energy. So when we make an energy profile diagram or energy diagram, so we have reactant with low energy and the product is having high energy. And exothermic reactions, opposite will happen. The reactants will have high energy and the product will have low energy. Now, for example, if a chemical reaction is endothermic reaction is there, in which, as we know, reactant is forming a product, and but it's also a reversible. Reversible means that both possibilities are there. Reactant can form a product can form back the reactant. If I increase temperature, so if I increase temperature, as you can see, the reactant is having a low energy and the product is having high energy. So what I will get more if I supply energy? Which substance I will get more? If I supply energy, I'll get more product. So when I supply energy, the reactant will form more product. So for endothermic reaction, when we increase the temperature, if we get more product, what we say, the equilibrium or the balance?
The left and the right.
Shifted towards right hand side. Because if product is more, we say equilibrium is shifted towards right hand side or forward. But what will happen if I decrease temperature? Decrease temperature means removing the energy. If I decrease temperature, what I will get more? Which substance will form at a greater amount? So if I remove the energy, the product will lose most of its energy and it will form back the reactant. So decreasing a temperature, how it will affect decreasing a temperature? The equilibrium or the balance shifted towards left hand side, or you can also say backward. Is it clear? The effect of temperature for endothermic reaction, reversible reaction, which is endothermic. So if a reversible reaction is endothermic, I supply energy, so I will get more product, or equilibrium shifted towards right hand side. And if I remove the energy, I decrease the temperature, so I'll get more reactant. So I will say equilibrium is shifted towards left hand side or backward. And if you have exothermic reaction means reactant have high energy and the product is having low energy. And I'm increasing a temperature. If I increase the temperature, where the equilibrium will shift? So it will shift towards reactant side because I'm supplying energy. So most of energy absorbed by the product and product will form reactant back again. So if product is forming more reactant, what we say equilibrium shifted towards left or backward. And if I decrease the temperature, where the equilibrium will shift? The balance. If I remove the energy, so if I remove energy, most of energy is lost by the reactant and it will form back the product. So we'll say equilibrium or balance is shifted towards right hand side or forward. So I will repeat what we discussed here about the temperature. As what is the effect of temperature on equilibrium or balance? So as we know, the reaction can be an endothermic reaction, it can be exothermic. If it's an endothermic, reactant have less energy, product is having more energy. If it's an exothermic reaction, reactant have high energy and the product is having low energy. So what happened? If I increase the temperature, means I supply more energy. I have both reactant and product. But if I supply more energy, most of the reactant absorb energy and they will form the product. So if most of the reactant absorb energy and form the product, so where the equilibrium will shift? Equilibrium will shift towards right hand side. And if I decrease the temperature, I remove the energy, so product lose most of its energy and it will form reactant back again. So where the equilibrium will shift? The equilibrium will shift towards left hand side or backward. And opposite will happen for exothermic reactions. Reactants have more energy, product is having less energy. So if I increase the temperature, product absorb most of its energy and it will form the reactant. If I decrease temperature, reactant lose most of its energy and form back the reactant. Copy this part. Any doubt in this? For exothermic reactions, when we make an energy profile diagram, so reactants have high energy and the product is having low energy. And because this reaction is reversible, so means you have both reactant and product. Both of them are existing. And which one is having a high energy? Reactant is having a high energy, whereas product is having a low energy for exothermic. You are supplying energy. So example, you have a container which is having both reactant and product and you supply energy. Reaction is giving out energy and you're also externally you're supplying energy. So if externally I will supply energy, what will happen? I have both reactant and product. You can see product energy is low. So if I supply energy, which one likely to absorb greater amount of energy? The product likely to absorb greater amount of energy. As the product will absorb energy, what it will form? It will form back the reactant. So heat is supplied to a container which is having both reactant and product, but because the product energy is low, so most of the energy is absorbed by the product and it will form back the reactant. Is it clear now?
Yes, sir, but why when we decrease temperature it forms product?
Why we decrease temperature, it forms the product. So what happened? You're removing the energy. So if I'm removing the energy from this, we have both reactant and product. So if I remove energy, which substance is having a greater amount of energy? Reactant or product?
Reactant.
Reactant. So most of the energy is lost by the reactant, as most of energy is lost by the reactant, what it will form more? It will form greater amount of product. Because when the energy is removed from the reactant loses their energy, and as a result, what they will form, because the product energy is low, so they will turn into product.
Okay, sir. Understand.
Okay.
Thank you, sir.
So reactant and product energies are different for exothermic and endothermic reactions. The third factor which affects the equilibrium is known as a pressure. Effect of pressure on position of equilibria or equilibrium. Keep in mind, pressure only affect the gaseous reactant or product. If reactant or product are in a gaseous state, then only there is an effect of pressure. Otherwise, there is no effect of pressure. So example, you have, if we have or if we increase pressure, equilibrium shift towards side where number of particles of gas are less. So if we increase the pressure, equilibrium shift towards side where number of particles of a gas are less. What does it mean? For example, nitrogen is reacting with hydrogen and the reaction is reversible. This result in a formation of ammonia. But as we mentioned, it should be in a gaseous, either reactant should be a gas or a product should be a gas, or both of them, reactant or product, can be gas. Nitrogen is a gas, hydrogen is a gas, ammonia is also a gas. So how many particles are there for the reactant side? How many particles, total number of the particles? So how you can work out 3 particles of hydrogen and 1 particle for nitrogen. So total number of reactant particles are 4. The number of the molecule here, I mean, the number of the molecules are 4. How many particles or molecules of a product are there? It is 2NH3. So how many molecules or the particle of product are there? So that's equal to 2. So reactant side you have 4 particles, product side you have 2 particles. Example, you have a container, because you have this container, and this is the original position of the piston. Nitrogen is there, 3 molecules of hydrogen, and ammonia is there. If I increase pressure means I will push this down. Because to increase the pressure, I should reduce the volume or compress the gas. So if I increase the pressure, what will happen? The term increasing a pressure means reducing a volume. So which case the particles have more collagen? Here I increase the pressure. At A or B, which one particles have more collagen? In B, the particles, because they are closer to each other, frequently they will collide with each other. And which particle are more? Yeah, because less volume is there, so more pressure, more collagen, particles are closer. So it means because a small space. So here what happened? We have a small space and less number of so there's a small space and more particles of reactant. So they collide often, which result greater rate for formation of product. So where the equilibrium will shift in this example, if I increase the pressure, I have 4 reactant particle, I have 2
In the
product particles.
reactant, because more particles, so more collisions.
So reactants, more particles, more collagen. As the reactant collide more often, they will result in a formation of a greater amount of product because the reactant particle collide and they form a product. So which one, where the equilibrium will shift in this example? So if I increase the pressure, equilibrium will shift towards right hand side or forward. As you can see, in increasing a pressure always shift the equilibrium towards side where number of the particles of a gas are less. So if I have 4 reactant particle, I have 2 product particle. I increase the pressure means I reduce the volume. As I reduce the volume, because in the mixture I was having more reactant particle, so they will collide more often. As they collide with each other, this will result in a greater rate of formation of a product. That is why equilibrium will shift towards right hand side. Is it clear? The effect of pressure on the position of equilibrium. So this statement is important. If we increase the pressure, equilibrium always shifted towards side where number of the particles of gas are less. So you check here, we have 4 particles of gas, 2 particles of gas. So where equilibrium will shift? Equilibrium will always shift towards side. If I increase the pressure, it will shift towards side where number of particles are less. Yeah, shifted right, not left. In this example, it's right. So increasing the pressure, reduce the volume. We have greater proportion of reactant particles. They collide often. As a result, the equilibrium will shift towards right hand side or forward, not left. By mistake, I told left, but it is towards right hand side. So these are the 3 factors which affect the equilibrium. One is the adding a reactant or removing a product. The second one is temperature, and the third one is pressure. But if you have equal number of the particles, like say another reaction in which A is there reacting with B and forming a product C. But keep in mind, they should be in a gaseous state. So A is example a gas, B is also a gas, and C is example a gas. How many reactant particles are there? How many particles of reactant? Total number of particles of reactant? We have 2 reactant particles. How many product particles of the product? 2. So if you have equal number of particles for both reactant and product, so there is no effect of pressure. In this example, the pressure will not affect. So even though the reactant are in a gaseous state, but the pressure will not affect because you have equal number of the particles of reactant and product.
Sir,
Yes.
sir, this number 4, sorry, reactant 4 and product 2. This
Yes.
is the grams or what?
No. This is called a mole number. Like we have 1 mole of nitrogen and we have 3 moles of hydrogen. So means the total number of moles or total number of molecules are 4 according to simplest ratio. Like according to simplest ratio, for a reaction, I need 3 molecules of hydrogen and I need 1 molecule of nitrogen to form 2 molecules of ammonia. But what happens if I compress them? So I have both reactant and product, but because I compress, so what it increase? It increase the chance of collision between the reactant particle. Why? Because they are in a greater proportion. That's why it is shifting towards right hand side.
Okay.
So only these 3 factors affects the equilibrium or a balance. Other factor does not affect the equilibrium or a balance. Uh, we'll do some questions now. Finish writing this. And if equilibrium shifted towards right hand side or forward, if we sketch a graph for percentage of ammonia, or percentage of a product or percentage yield. Percentage yield refers to how much product is there. So the yield will increase. And if equilibrium shifted towards left hand side, or backward, if we sketch a graph for percentage yield means amount of product versus the pressure. It means the percentage yield will decrease. You don't have to copy this graph. This is just an idea that how the graph will appear if the yield increase or yield decreases. Now we'll discuss some questions so it will improve your understanding of the topic. related to reversible reactions. Okay, in this question, steam reacted with carbon and it is an endothermic reaction. Okay, the reaction is endothermic. Which conditions of temperature and pressure would give the largest yield? So first thing, to understand a question, what you should do, because a reaction is endothermic, so you can make an energy diagram. If I make an energy diagram, reactants have, for endothermic reactions, reactants have low energy, the product is having high energy. So reactant here is carbon plus water, and the product is carbon monoxide plus hydrogen. Now, I want greater, largest yield. Yield means amount of product. So what I should do here, it's an endothermic reaction. I want higher amount of product. So what I should do, increase the temperature or decrease the temperature? Because I want more product, so I should increase the temperature. So first thing is the temperature must be increased. So either A can be answer or B can be answer. Then what about pressure? First, you should check the number of the molecules. So when you check the number of molecules of gas, how many molecules of gas in the reactant side? 1. How many molecules of the gas in the product side? 2. So if I increase the pressure, where the equilibrium will shift? If I increase pressure, equilibrium will always shift towards side where less moles are there. So where the equilibrium or the balance will shift? So if I increase the pressure, the equilibrium will shift toward left. So if the equilibrium will shift toward left, I will not get a higher yield. So I need a lower pressure. That's why B is the right answer. Is it clear? Because if I increase the pressure, equilibrium shift toward left hand side. Equilibrium shift toward left hand side means the yield or amount of hydrogen will decrease. But I want greater amount of hydrogen, so I should not increase the pressure, so that equilibrium will not shift towards left hand side. That's why we need a lower pressure. So higher temperature and lower pressure will give us higher yield of hydrogen. Any doubt in this part? Yeah, H2O is water vapor. If a temperature is high, it is water vapor or steam. You can see here, it's written steam. So water vapors are there. H2O, water can be in a vapor state. It can also be in a solid state like ice. It can be a liquid state, or it can be a gaseous state. So water is produced in a gaseous or reacted at a high temperature. So it is in a gaseous state. So you will consider the equation state symbols are given. That's why you're taking according to that part. These conditions apply to a reaction mixture, because in a reversible reaction, you cannot say these conditions apply to reactant, or you cannot say these conditions apply to product, because for a reversible reaction, you have both reactant and product. So you should maintain a high temperature and reduce the pressure to get more hydrogen from this reaction. So I should continuously supply heat energy, and I should continuously supply heat energy and reduce the pressure or increase the volume, so I will get greater amount of hydrogen. Nitrogen, hydrogen, and ammonia are placed inside a container. So reversible reaction, all of them are there in the container. The container is then sealed. After some time, an equilibrium forms. Which statement describe the equilibrium in this container? What's the meaning of equilibrium or balance? What could be the answer here? The amount of ammonia remain constant for a moment. No, not for a moment. That's A is not for a moment. It will remain constant throughout. Why B cannot be an answer? Amount of ammonia, nitrogen, and hydrogen always equal. No, their amounts are not equal. It's not like you have 2 grams of nitrogen or 2 dm cube of nitrogen, 2 dm cube of hydrogen, and 2 dm cube of ammonia. That's wrong. The term equilibrium means there is no change in the concentration or the amount. So the rate of formation of ammonia means the way ammonia form is same as the rate of decomposition of ammonia. So ammonia decompose and form nitrogen and hydrogen. The rates are equal. No change in concentration, but it does not mean we have equal amount of reactant and product. Equilibrium does not mean that you have 2 grams of reactant and you have 2 grams of product. That does not mean equilibrium. Equilibrium means the speeds are same, the rate of the forward and the rate of backward reactions are equal. So that there is no change in concentration of reactant or product. Is it clear? The reaction used to manufacture ammonia, nitrogen, hydrogen reversible at an equilibrium established between them. Which statement describe equilibrium? What's the answer here? Yeah, A is the right answer. That the forward and the backward reaction have the same rates or same speed. Everyone should participate so it shows your understanding of the topic.